Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 23 of the subject of software quality engineering, in which we are going to discuss the software quality metrics, and this is the second part of the lectures. And here the topic is the process and product metrics for software quality. Dear students, in the previous lectures, we have briefly discussed the introduction about the software process metrics in the software quality. So here we are discussing the process and product metrics, which are very much important metrics used for software quality improvement. This is the discussion agenda. It contains the topics of software's size, volume measurements. Here we will show you how to measure the volume of the program. Then we have process metrics categories. So here we will define different categories of the process metrics. Is kilologs enough? That means that we will discuss that kilo line of code is enough or not. And then we will perform some comparisons of the case studies. Then we have the error density matrix and the error severity matrix. Then we have the software process timetable matrix. And then we have the timetable matrix example. And then we have the error removal effectiveness matrix, process productivity matrix. Then we have the product matrix categories. Here we will discuss different kinds of the product matrix. Then we will discuss the HD call density matrix. So that is the help disk call density matrix. Then we will discuss the severity of the help disk call matrix here. Then we will also discuss the success matrix and the productivity and effectiveness matrix of the help disk matrix. Now, software size, which is also called the volume measurements. Basically, we measure the size of the software in the kilo line of code. So, kilo means that 1000s. Here we represents the line of code in terms of kilolog, and that is the program statements. Every interpreter or compiler provides the certain number statements. For example, the C#.NET contains line of code, and here all the statements are listed. And in fact, in every class, if we have a certain class which contains certain codes, all code is in fact provided are numbered with this particular some numbers, and these numbers are properly counted, and these numbers are represented in the matrix called volume matrix or the size matrix, and that is measured in the kilo line of code. So classic, it is a classic matrix, means that this is very much old theoretical matrix, or the theory about the kilolog is quite classical, which measures the size of the software by thousands of code lines. Thousands of code lines means 1 kilolog. So number of function point is another examples of the size matrix here. The software size can be represented by the function points. Function points means that the functionality in the softwares that is properly calculated with an NFP, that is number of function points, and it measures the development resources, including the human resources required to develop a program based on functionality specified for software systems. So all the functionalities are in fact here represented, and they are in fact corresponded with the human resources. The human requires to complete that particular functionality. For example, 10 software engineers are required to complete the system for the banking systems. So are the 30 people or the software engineers are required to complete the online ordering system for a watch company. So here we will divide the functionality of a software into multiple sub-functionalities, and each functionality or sub-functionality will be completed by the people or group of people, and these people are the software developers. Now, process matrix categories. There are different categories of the process matrix. So, all these process matrix and the categories are used to assess the quality of the products, and these are called the software process quality matrix. This includes error density matrix and error severity matrix. These are the software process quality matrix. Similarly, we have software process timetable matrix as well. And then we have software process error removal effectiveness matrix. And at the end, we have software process productivity matrix. Now, we will discuss each and every of these matrices in the upcoming slides. Now, the question is that is kilo-like is enough or not? So, what about the number of errors? That is the error density. And what about the types of error? That is the error severity. Now, you must know about that the error density is different than the error severity. Error density means number of errors, while the severity of the errors is in fact the effectiveness are the challenging errors which are quite difficult to be corrected. So the error density and error severity are two different things. A mixture of kilologs, that is the 1,000 line of code, density and severity is an ideal quality matrix to programmers for quality of work and performance. So we will use all these three metrics in for the software quality measurements. Now here we are comparing, for example, there are two projects and the programmers are working on these two projects. So programmer A produces 342 errors during the software process before release of that one project, while the programmer B produces 184 errors. So we can say that this programmer B is better than programmer A, but in fact they cannot be equal to each other because depends on the severity of errors. We cannot compare the number of errors with each other for two different projects. So what is in your mind that which programmer do you think is better? So generally we think that programmer B is better than programmer A, as programmer B has generated less amount of errors as compared to the programmer B. But the reality is not so. That it depends on the severity of errors as well. So it depends on the types of errors found, that is the severity, and not only the number of errors, which is the density. So severity is more important than the density. One error of high severity might be more important than hundreds of other types of errors. Sometimes the errors may be in fact in the hundreds or thousands of errors, and they are quite simple to be fixed as compared to just one error, which is very much severe errors. Now, error density matrix. We have different examples of the types of error density matrix. Here, according to the standard CED, which is the code of the code error density, CED is the particular abbreviation or code for the used for documentation purpose. Here we have the code error density. The code error density can be computed as like that CED is equal to NCE divided by kilo log line of code, where NCE is the number of errors detected by code inspection and test. So number of total errors detected by the inspection divided by 1,000 lines of code. So this is CAD matrix. Next one is DED matrix. DED is the development error density matrix. Here DED is equal to NDE divided by kilo line of code, while NDE is total number of development designs and code errors detected in the development process. So all the errors that are detected in the development process, NDE divided by 1,000 line of code, that is DED matrix, which is the development error density. Next one is WCD matrix. WCD stands for the weighted code error density. And here WCDE is equal to WCE divided by kilo line of code, where WCE is the weighted total code errors detected by the code inspection and testing. So all the code errors are counted here and it is divided by 1,000 line of code of the projects. Similarly, next we have weighted development errors density. So weighted development error density is equal to WDE divided by kilo line of code, while WDE is total weighted development designs and code errors detected in the development process divided by 1000 line of code. Similarly, we have weighted code errors per function points. So that means that errors identified in a particular function points, which is the functionality in of the system. So functionality may be just one function. For example, printing is one function or searching. So that matrix is equal to WCEF is equal to WCE divided by NFP, while WCE is weighted total code error detected by code inspection and testing divided by NFP. So here you will in fact find that all the non-functional points here, and non-functional points are used as a divisor here for this WCE value. Then we have WDEF. WDEF is weighted development errors per function point. So weighted development errors per function point is equal to WDE divided by non-functional points, where WDE is total weighted developments, that is the designs and code errors detected in the development process. Now we have also another matrices here of the error severity matrix. Then there are two error severity matrix. One is called average severity of code errors and second one is called the average severity of the development errors. So here average severity of code errors is equal to ASCE is equal to WCE divided by NCE, while WCE is weighted total code error detected by code inspection and testing divided by NCE. NCE is the number of code errors detected by code inspection and testing. Similarly, ASDE is the average severity of development errors. So here ASDE is equal to WDE divided by NDE, while WDE is the total weighted development designs and code errors detected in the development process divided by total number of development including designs and code errors detected in the development process. Now also we have a very much important matrix called the software process timetable matrix. So here we have two different software process timetable matrices. So one is called TTO and second one is the ADMC. Well, TTO is the timetable observance. So timetable observance is equal to TTO divided by MSOT divided by MS. Well, MS is milestones completed on time divided by total number of milestones. Dear student, these two matrices are in fact used for the analysis of schedulings or the times or framework required to complete the projects. Similarly, we have the average delay of milestones completions. Average delay of milestones completion is equal to TCDAM divided by MS, while TCDM is the total completion delays, that is days, weeks, etc. for all milestones. Now we will in fact conduct some examples of these matrices. So there are the TTO matrix examples here. So for example, if we have the milestones are requirements analysis, design, implementation and testing. So you can see there are 5 milestones: 1, 2, 3, 4 and 5. And milestones completed on times are only requirements and analysis, while design, implementation and testings are late. So that's why TTO value will be 2 divided by 5. So that means that all milestones completed on time divided by total number of the milestones. Similarly, we have ADMC matrix that is in fact used for the scheduling purpose. And for example, if we have requirements which is 1 week delay, similarly analysis is 3 weeks delay, and design is 2 weeks delay, and implementation is 6 week delay, and testing is 2 weeks delay. So you can see that there are multiple types of delays in multiple phases. So overall delay is 14 weeks. If you count all these delays, it is equal to 14 weeks. So ADMC is equal to number of delays divided by total number of milestones. So 14 divided by 5 is the ADMS value. Now we have the error removal effectiveness matrix as well. During the testing, we remove the errors, and errors are fixed errors. So we have the DERE matrix, development error removal effectiveness matrix. Here DERE is equal to NDE divided by NDE plus NYF. So NDE is the total number of development designs and code errors detected in the development process. Similarly, NDE plus NYF. So while NYF the number of software failure detected during a year of maintenance service. So these are used for the in fact identification of the errors and then correcting different errors. Similarly, DWER is development weighted error removal effectiveness matrix. It is DWER is equal to WDE divided by WDE plus WYF. While here WDE is in fact the total weighted development design and code error detected in the process divided by WDE plus WYF. So WIF is weighted number of software failure detected during a year of maintenance service. So all these are used for scheduling purpose. These metrics represents that how the errors are identified and they are corrected within the time or they are late. Now, for example, DERE matrix can be computed by number of errors detected in designs and coding stage. For example, if these are 100 and number of errors detected after 1 year of maintenance service is 500, so DERE is equal to 100 divided by 100 plus 500. That is 100 divided by 600, which is equal to 1 over 6. So that means that DERE is in fact a value which is divided by the errors detected in design and code stage is divided by number of errors detected after the particular times frame was plus the original errors. So that is in fact the when the after particular times when some new errors are detected, then original errors plus new errors is in fact is added together and 100 divided by 600, which will be in fact a particular point value here. Now also we have the process productivity matrix. Here development productivity matrix is equal to DEVP. So DEVP, that is development productivity matrix. These all metrics are used to measure the development process of the software systems and at in fact used for the productivity of the programmers. So development productivity is equal to DEH divided by kilo line of thousand, of course. So here total working hours invested in the development of the software system is development hours. So all the development hours are added divided by 1000 line of codes. Then the particular value is obtained, that is the development productivity matrix. Similarly, we have the function point development productivity matrix. Here the particular function points are counted and then the matrix is calculated using FDEP. So that is the function point development productivity is equal to development of hours invested in the development of the software system. That is the total number of hours invested in the development of the software system divided by number of function points. So all the number of function points are counted here, and then we have the code reuse matrix. Means that if we have are reusing the codes of the previous projects with the in the current project, that is code reuse matrix is equal to RE kilo line of codes, which is the number of thousand of reused lines of code divided by thousand of line of code. So reuse divided by total number of thousand line of code in that particular projects. So all these values will be in the fraction point, that is in the point. Next one is documentation reuse. Similarly, RE docs divided by number of docs. So reusable number of pages of documentation divided by number of pages of documentation, that is total number of pages in the documentations. Also, another type of matrix which is called the product matrix. In the product matrix, we in fact measures the product, the metrics which are relevant with the product being developed. So here, first matrix is called help desk matrix, HD quality matrix. These matrices are used for representing the quality of the software. So HD call density matrix measured by the number of calls. So here we measures the number of calls. When the particular function is called here, then we can say that the help desk matrix measured by the number of calls. Similarly, HD call severity matrix is the severity of the HD issue raised. So all the issue of the help desk, that is mean that the issue raised by the customers are in fact measured here in the form of the HD call severity matrix. Then we have HD success matrix is the level of success in responding to HD calls. So when the customers calls are in fact the customers calls the helpline when there are certain problems in the project, then the HD success matrix is the level of success in responding to HD calls. Now HD productivity matrix, similarly we have HD effectiveness matrix and corrective maintenance quality matrix. All these are different types of the help desk matrix. We will discuss all these matrix in the upcoming slides. Now corrective maintenance quality matrix includes software system failure density matrix, means that what is the density of the failure of the software. Similarly, we have software system failures severity matrix, means that what is the severity of the failures. Are the failures are very much severe or less severe? So all severe matrices are failures are counted here, and failure of the maintenance service matrix means that they, in fact, during if the maintenance is also failing, then all these failures are counted, and these are properly documented in the form of the matrix. And similarly, software system availability matrix means that software is available, that is the uptime of the software is measured here. Corrective maintenance productivity and effectiveness matrix is also one of the types of matrix, that is the we have the maintenance productivity, means that how our productivity is in fact in terms of the maintenance of the old softwares, and how the productivity or the maintenance is effective here. Now these are the help desk call density matrix. HDDD is means that help desk call density, means that how much times the user have called the help desk. So here HDDD is equal to NHYC divided by kilo KLMC. So here NHYC is the number of HD calls that a help desk call during a year of services divided by thousands of lines of maintained software code. So here all these number of lines of codes in form of the kilo line of code which are maintained code. And similarly, weighted HD calls density is equal to WHYC is equal to WHYC divided by kilo line of maintains codes, while WHYC is the weighted HD calls received during 1 year of the matrix. So all these metrics are in fact used for the maintenance, the help desk, and they are also relevant with the maintenance. Similarly, we have the WHDF matrix, weighted HD calls per function points. So that means for the particular function points, if we call the help disk, then this matrix is equal to WHYC divided by NMFP, while WHYC is the weighted HD, that is help disk calls received during 1 year of services. During 1 year means that in the first year of service divided by the number of function points to be maintained. So all these number of function points are scouted here, and they act as a divisors here. Now severity of HD matrix. This is another types of matrix, that is average severity of the help desk call is equal to ASHC divided by WHYC divided by NHYC, while the WHYC is the weighted help desk calls received during 1 year of services divided by number of help desk calls received during a year of services. So that means that we are in fact considering here just first years, and we says that in the first years what is the value of average severity of the help desk calls. So that means it represents that how the software is more reliable and what is the complaint ratio of the users. Similarly, we have HD success matrix. HD is the help desk success matrix. So help desk service success is equal to HDS is equal to number of yearly help desk calls completed and on time during 1 year of services divided by number of help desk calls during a year of services. So here the number of help desk calls which are in fact completed for the particular time period of 1 year is in fact ratio with the number of calls during the year of the service. Now, also we have the help desk productivity and effectiveness matrix. Here's the help desk productivity matrix is equal to HDYH divided by KLNC, where HDYH is the total yearly working hours invested in help desk servicing of the software system divided by 1,000 line of all 1,000 line of maintain code. That means that all codes which is in fact used here. This is KLMC, which is the 1,000 of lines of maintain software code. Now also we have the function point help desk productivity matrix. This matrix is relevant with the function points, and for the particular function point the help disk is called here, and it is in fact counted for the productivity. So this one is in fact created for the full projects, while this one is created for the particular function points. So FHDP, that is the function point help disk productivity matrix, is equal to HDYH divided by NMFP, while HDYH is here the total yearly working hours invested in help desk servicing of the software system divided by uh, number of function point to be maintained. So all the number of function points maintained are in fact certain values which we required to be maintained. Similarly, HD effectiveness, that is help desk effectiveness, is equal to HDE divided by HDYH divided by NHYC. So HDYH is the total yearly working hours invested in HD services of the software system divided by number of help desk calls during a year of services. So all these matrices are in fact used for the maintenance purpose, and maintenance means that how the quality is there. So for example, I have certain questions that, for example, what is the ideal value of HTP? So how we can say that what should be the ideal value? For example, if that is the total yearly working hour investment in HD services of the software divided by 1,000 line of the maintain code. So means that here we will divide the hours, that is the hours in the yearly hours divided by 1,000 lines of maintain codes. So that means that if we are maintaining more codes than the hours passed, so automatically the values will become smaller and smaller. That is in the, for example, value will tends towards the zero. And if the hours are increasing then the maintained codes, so that means that the value will tends towards the one or more than one values. For example, something values like 10.5, and if the maintain code is becoming more and more than the number of hours, that means that maintenance is quite efficient. So the ideal value here, it is in fact closing towards the zero. That means nearly, if it is equal to zero, that means that our productivity for the maintain code is quite high. So HD productivity value will be high here. Similarly, you can also think about all these matrices. So these matrices are very useful matrices for assessing the quality of the product. Dear student, this is the end of this lectures. These are two very good books. You should study these books. These are about the matrices and model in software quality engineering by Stephen H. Ken, and similarly computational intelligence in software quality assurance by Scott Dick, Abraham Kendall. So this book is very good book. I hope that you will enjoy this book and you will get more knowledge when you will read this book. Also, if you have any question, you can ask this question through the email. My email is m.kardim@kust.edu.pk. I will wait for your questions and will respond immediately if I get your questions. Thank you very much.